Hello and welcome back to Bioscience. This lecture is all about microscopes. So that is what I'm going to title my notes today. This is all about microscopes. Microscopes are how we can see stuff really, really small. They're basically like really fancy magnifying glasses. So microscopes are ways that we can make observations, ask questions, do experiments, and observe, what's going on there. We can see really small things. We can magnify them a lot more than we could with just a simple handheld microscope. So this is really important. There's some types of microscopes that we'll talk about. There's only 3 types that we're going to talk about in this class. The most commonly found one that you'll find in like any undergraduate level biology class is a compound light microscope. That's our first type. Type number 1 is called compound light microscope. A compound light microscope uses light in a series of mirrors in order to magnify stuff a certain way. And here's a picture I'll show you. But first we're going to draw a picture so we can kind of like get an idea about what's going on. So in our compound light microscope, we have like just the base. That's where all the power stuff is located, including like your on and off switch, and then the cord comes out and plugs into the wall. But from this base, we have this thing that emits light. So that's all light coming out of there. And then that will meet the stage. So this is the light source. This guy is the stage. Lights, camera, action. You know what I mean? That's the stage. That's where stuff happens. That's where the light is going through. And how the light goes from, notice that the light here is underneath that stage. So there has to be a little hole in the stage. That hole in the stage is made by this guy called the condenser, which helps regulate the amount of light going to that stage. And the stage is where we would rest a specimen. So if I were to take a little, we call it a slide that sits on a microscope. So it's like this little, usually a rectangular little glass thing that has your specimen there in the center. Maybe it's cells, maybe it's leaves, something that you want to look at. So that's cool. So that's your specimen there. And how you look at that specimen is, so this light comes through our light source, through the condenser, through the stage, through your specimen, and notice that that stage and that specimen is on like a piece of glass so that we can kind of see through it, right? And everything goes through what we call the objective lenses. So the objective lenses, we'll draw 3 just for fun. And it's kind of like on this rotating piece so that we can change how much we're zooming in. So those guys, they're called objectives. Objective lens. And the objective lenses can be either like low, medium, or high power. Low, medium, or high power, and it can magnify things a certain amount. So low power, typically it magnifies things 5 times bigger than it normally is. Medium is typically like 40 times how big the item is, and then finally high is usually 100 times bigger than it would appear to the naked eye. So all of those objective lenses display that image, which then hits like this mirror that hangs out in here. There's like a little mirror in there, and then that's where we see it through. We have these little eyepieces. Those are the ocular lens. And that's what we see through. And the ocular lens actually has a magnification itself 10 times bigger than we would see with our normal eyes. So the ocular lens has its own magnification plus the magnification of the objective lenses. And all of that's happening because we're looking at this light source going up through the objective lens, bouncing off that mirror to get through into the ocular lens. That's my cartoon image. it looks much fancier than this in real life. Let me show you. Okay. So here's what it looks like in real life. Much fancier than what I've drawn you. So this is what you'll find in like a normal biology classroom. So notice that we have our light source here, emitting light. There's that condenser going through, those objective lenses bouncing off a mirror, and then out that eyepiece, that ocular lens. And notice that where we have our objectives, it's on this rotating thing, so you can change how zoomed in you are. So that's a compound light microscope. And the thing about compound light microscopes is because we have this 10 times magnification plus our whatever we're looking at with the objective lens, we can make things a lot bigger than we could normally see with our eyes. So for example, if we were on the low power objective, so the low power objective magnifies things already 5 times. Oops, I want my real pen. 5 times. But then we're also, that light is passing through that low power, then also through that objective lens, which is also magnifying. And so what actually happens is even on the lowest power objective, we're still magnifying things 50 times. That's a lot. So if I follow a similar method here, medium, that would be, let's see, we have 40, and then our ocular lens, so that would be 40x. 10x for the ocular, and that would give us 400 times. That's a really big step up there. And then finally the high power objective would be, well, that's 100 times. So 100 times, then 10 times still for that ocular lens. That's 1,000 times bigger than we could see with our normal eyes. So microscopes, even compound light microscopes, are really, really awesome. Okay, an even more awesome microscope than a compound light microscope is what we call an electron microscope. So that's microscope number 2. Electron microscope. An electron microscope is really fancy and it's really spendy. Lots and lots of money to buy those. We don't typically find those in undergraduate classrooms. However, they can tell us lots and lots of really cool stuff. We can magnify things up to like 10 million times bigger than we can see with our normal eye. So let me show you some pictures. Stuff we can see with an electron microscope. We could look at maybe like pollen that makes you sneeze, you know? Pollen on an electron microscope, and we could go through into this image and maybe make it colorful if we wanted to. An electron microscope can make pollen, teeny tiny little dust particles that make us sneeze in the springtime, really, really big and really viewable. Something even yuckier, maybe a bed bug. So this is all stuff we could see with electron microscopes. So we can get really, really fine details. And magnify stuff a lot. So electron microscope, that's microscope number 2. And the third one, that microscope number 3, that's called a dissecting microscope. Dissecting microscopes are better than a handheld microscope, you know, one like Sherlock Holmes carries around. But dissecting microscopes are used while we do dissections, but it's for seeing stuff that maybe we don't need to magnify as much. You can get up to 80 times bigger than you see in real life, 80 times magnification. And the microscope that you use depends really on what you're trying to see. If you're trying to see something like little hairs sticking off of a leaf, well then, yeah, maybe dissecting microscope's your guy. But if you're trying to see some cells that are doing mitosis, compound light microscope totally works out really well. If you're trying to get super fine details, then that's where you're looking at electron microscopes. And also if you have like a bunch of money to spend to buy an electron microscope. So that's microscopes. And we have one more video this week, but I hope you have a great day.